to extend your warranty past the factory cutoff. And this is a courtesy call to renew your warranty the file. If you are interested in renewing warranty now, please press 5 now, or press 9 to be removed from our list.
All right, good morning. All right, so we're gonna have an exam tomorrow. That's 1415 morning. Just a reminder on your assignments are be done in pencil. So I don't accept any pen. That means your scratch paper also needs to be done in pencil. So I only accept work in pencil. Make notes in colored pens. You can write notes, but your notes, scratch paper, and assignments have to be done in pencil. Okay, just a reminder about the scratch paper. Your scratch paper, I'm giving you 14 problems. You have plenty of time to do everything that I want. On every problem, you have to write the original problem. You have to work the problem or graph or whatever and circle your answer, and that's on every problem on the exam. If you do not show that, I will not give you credit for the exam. All right, today we're going to be doing more on transformations. So the first time I taught transformations was in the prerequisite section, and I gave you a lot of material. I gave you problems. Those of you who did the extra work, you're good to go. Those of you who didn't do it, this is your last chance to get caught up with transformations. If you miss it this time, you're going to miss it in the future. So I'm not teaching it again after this. So this will be the final time that I teach it. So before we get started, does anybody want to ask me any questions about the exam 1415? The way you want to study for the exam is you want to work on the e-text. You want to work problems. Anybody want to ask me any questions about problems for the exam?
How many questions is it?
14. We'll say this on page 226. Do not worry about problems 9 through 12. Those are more difficult problems. I didn't assign any of those. Make sure you know how to do problems 5 and 7 on page 226. So when I let you break into your Math Wizard teams to work on this new assignment, I do recommend that you try to do on page 226, 5 and 7. Those two problems are absolutely on the exam. So let me just ask you this. What do you know about the slopes of parallel lines? What do you know about the slopes of parallel lines? What do you know about the slopes of parallel lines?
They're equal.
They're the same. So you have to know that for problem number 5. You have to know that you're going to use the slope of the other equation for parallel lines. What do you know about the slopes of perpendicular lines? So if you have an equation like 2/3 x minus 7, what do you know about the line that's perpendicular to him? What do you know about the slope? Oh, okay. Well, what's his slope then? What's his slope?
2/3.
2/3. So if they ask you to write an equation of a line that's perpendicular, what do you have to do for the new slope? So we know his slope is 2/3. What do you have to do with the new slope for perpendicular lines?
Make it negative.
And what else? You have to take the reciprocal first
Flip it.
and then make it negative, right? That's right. So let's do another one. Now, if they're parallel, you use the same slope. Okay, so you have this guy. He's y equals negative 1/5. Words away. Negative 1/5 x minus 2. If you were dealing with parallel lines, what would your new equation be? What would the slope of your new equation be?
Negative 1/5.
Right, it would be the same. It would be the same. But if you're dealing with perpendicular lines, you would need to find a slope, right? So what would the new slope be?
5.
5/1.
It would be the reciprocal, and a negative of a negative is a positive. You're right. 5/1. 5. Make sure you know that. So that's super critical that you know that for problems 5 and 7, that parallel lines have the same slope. Perpendicular lines, that's perpendicular, you have to take the reciprocal and negate it. So the negative of a negative would be a positive. Okay, before we go on, does anybody want to ask me any questions on 1.4 or 1.5?
The 2021 see your email report. To hear this message again, press 1. To opt out of messages like this, press 0.
That's my landline that keeps going off. It's like it never rings, and now it just wants to ring a million times during my lesson. So sorry about that. Anybody want to ask a question about 1.4.1? Is it 1.4.1.5, right? Yeah. Last call. Any questions? Okay, like I said, the best way to study for this exam is to do the globe problems. If you can do the globe problems, you should be good to go. If you don't study, then I can't tell you, the scores are going to be like they were last time. So you can tell who's studying and who's not. All right, so the next section is 1.6, and we're going to look at transformations again. And I just want to show you some things that I've already given you. So I'd like to share my screen with you. This is in your classroom. And so this is what mine looks like. We're in Precalculus 2. This is your class. And if you go to my classwork, under materials, I gave you this, the parent graphs. And so this is where we're going back to. So the parents are the most basic graphs. So there's your linear function. There's your quadratic. There's your cubic. Some of these we haven't done. Here's your absolute value. Here's your square root. Here's your cube root. So remember, these are the most basic graphs. Now, while we're here, let's talk about this real quick. Oh, I can't because you can't see my screen, so I'll wait. Okay, I also gave you, and I asked you to print these out, the sheet for transformations. So what I'm showing you here is just a basic function. This is for quadratics, though, that my TA helped me make. Remember, we want to know what A, B, H, and K do to the graph. Just to let you know, Precalculus book, it's not going to say vertical compression. It's going to say a vertical shrink. Compression means the same thing. Also, It's not going to say horizontal translation. It's going to say a horizontal shift or a vertical shift. So nothing to be alarmed about, just to know that different books use different terminology. We just don't want you confused with the different terminology. So remember that inside H is left or right. So this would be right 2. And in the form, this would be minus a -1, which would be left 1. Remember, K is just straight out up or down. And remember, K is outside the square. H is inside the square or the cube or the absolute value of the square root. K is outside the square, outside the cube root, outside the cube, outside the absolute value, outside the square root. A, which is outside the function, is vertical. So this would represent a vertical stretch. This would represent a vertical compression when you have a proper fraction, like 1/2, 2/3, 7/8, 11/12. Let's skip this one for a minute. Let's go to this one. When you have a negative outside, it's a reflection across the x-axis. When you have a negative inside the square, inside the cube root, inside the absolute value, inside the square root, it's a reflection across the y-axis. Now, this is the only weird one, this B. Remember, you have to take the reciprocal. So this would be a horizontal stretch by 4. This would be a horizontal compression by 1/3. So I did recommend, if you have a printer, to print this out, because this paper will work for all the functions that we talk about: the quadratic, the cubic, the cube root, the square root, the absolute value. It works for all of them. So I'm going to show you some things in your book, but I want to show you this first. Remember the parents, x squared, right? Remember the absolute value. Remember the parent of cubic. Remember, we didn't do too much of, well, we did square root, but we didn't do too much of the cube root. Hold on, I thought it was on the page. The cube root. Okay. All right. So remember what this guy looks like? It looks like a quadratic. This guy looks like a V. This guy looks like a snake. And he goes down and up, by the way. This guy is the inverse of the snake, which is left and right. So in a minute, when I write these points up here, they're the same. This guy goes up and down. This guy goes left and right. And this guy, remember, goes off to the right. So look in your books, please, on page 242. Oh, here we go again with the phone. All right. It's okay, I can yell over. On page 242, number 53. Are those problems, 53 to 66, what kind of parent are those? Who's the parent of 53 through 66? Come on, you guys. This isn't rocket science. Who is the parent of 53 through 66? On every single one of those problems, who's the parent? Pick them on the board.
X squared.
It's the quadratic. Okay, look at problem 67 through 88. Who's the 80?
Square root.
Square root. On problems 81 through 94, who's the parent?
Absolute value.
On problems 95 through 106, who's the parent?
The cubed root.
The cubic. And on problems 107 through 118, who's the parent?
The cube root.
Now, when you do all these problems, don't you need to know the parent points? Because when I taught this, didn't I say, state the transformation, show the transformational points and graph? So if you recall, the parent points were left one, up one, 0, 0, right one, up one for the quadratic, right? And I told you, if you forget these, just put in a -1, quantity squared is 1. A 0 squared is 0. A 1 squared is 1. Same for the absolute value. If you put in a -1, the absolute value is 1. If you put in a 0, the absolute value is 0. If you put in a absolute value is 1, those are the same as the quadratic. Okay, who are the points for the cubic? Who are the parent points for the cubic that you're going to transform? Come on, you guys, put a -1 in. What's -1 quantity cubed? -1. Put in a 0. 0 cubed is 0. Put in a 1. 1 cubed is 1. I know you can do that, right? You can do that, right? Okay, who are the points for the square root?
1, 1.
1, 1, and 0, 0, right? And the points for the cube root are the left one, down 1, 0, 0, right one, up 1. So for these two in particular, for the cube root and its inverse, I'm sorry, for the cubic and the cube root, the points look like this. But he goes up on the right and down on the left, and for the cube root, he goes right on the right and left on the left. So even though the points are the same, they're graphed differently. So the cubic always looks like this, the cube root always looks like that. Okay, now these are parent functions that we know about. Look on page 241, number 17. Now, number 17, function, he passes the vertical line test, but we don't have him in our list. So he is a function, but he doesn't have an equation. We're going to do number 18. So what we need to do is write down his points. So can you guys read up on the graph there? Please read off the points to me.
Left 4, 0.
Go ahead.
Down 2. Oh, sorry, left 2, down 2.
Left 2, down 2, 0, 0.
Right 2, up 2.
And right 4, 0.
Yes.
Okay, well, we don't have an equation for him, but who cares? He's still a function. And so in problem number 18, it says, okay, well, what is G? This is the F. What is G doing? So you tell me, what is G doing to F? I'm gonna dot that because he's not really there. We're just using him to look at. So what does this mean? Does it one, left one, up one, or down one? What does that mean?
Goes up one.
Right. So doesn't that mean we could take these points, left 4, 0, left 2, down 2, 0, 0, right 2, up 2, and right 4, 0, and count just the y up 1? Up is y, right? So can I just add 1 to y, add 1 to y, add 1 to y, add 1 to y, add 1 to y? So our new graph, isn't it left 4, up 1, left 2, down 1, 0, up 1, right 2, up 3, and right 4, up 1? So this is what I need on your scratch paper. This is what I need in your assignment. And this is what I need on an exam. Because it gets harder than this. We start doing vertical stretches and compressions. You can't just guess. So we need to eat the baby food before we can do anything more difficult. So this is saying move F up 1. So you're going to state that you're going to write the original problem. You're going to state the transformation. You're going to show the transformational points and graph. Let's do another one. Let's do number 30. Number 30 says to do this to the f function. Well, this is the same function, right? Now, one thing you don't have to do, you do not have to graph the original graph if you don't want to, but I do need the blue graph. So this is left 4, 0, left 2, down 2, 0, 0, right 2, up 2, right 4, 0. He's dotted because he's not really there. Okay, now just tell me this. Is that number, is it A, B, H, or K? Because that's what I need you to know. I need you to know what A, B, H, and K do to a function. So there's your A, B, H, and K. We know that H is left and right. We know that K is up or down. Is this A, B, H?
B.
It's B. Okay, now what do we say about B? Isn't he the weird one that we have to flip?
Yes.
So what is this then? Remember that B and H are everything inside is horizontal. A and K outside are vertical. H is left and right. B is horizontal. So be a horizontal what?
Compression.
Uh-huh. Well, no, is it a compression? Don't you have to take the reciprocal? Didn't we just talk about this?
Horizontal stretch.
Horizontal stretch by what?
By 2.
So doesn't a horizontal stretch mean this with our math aerobics out? So remember the points were left 4, 0, left 2, down 2, 0, right 2, up 2, right 4, 0. And doesn't a horizontal stretch morph the graph? Doesn't it change the graph? It doesn't just move the graph, it's going to change it. So doesn't horizontal mean we have to multiply the x by 2? Multiply the x by 2, wow. Multiply the x by 2, multiply the x by 2, multiply the x by 2, multiply the x by 2. The y's stay the same. And now this comes out 4, 5, 6, 7, 8. Left 4 down 2. 0 stayed the same. Right 4 up 2. And right 8, 0 is off my board. Sorry about that. But it's going to look like this. And doesn't that look like it was horizontally stretched? So this function, the black one, was f of x. And the blue function is g of x. But does it look like it was horizontally stretched?
Yes.
Okay, now, do you guys want to do another one? Let's do number 16. Let's do a harder one. So this is a different graph, and it's giving this. And this graph's different. We do not have a parent for, but it is a function. And it's left 2, up 2. And it's right 2, up 2. And it's 0, up 2. Okay, now what we're going to do is we're going to state the transformation first in the correct order. And then the transformational points are going to be left 2, up 2, 0, up 2, and right 2, up 2. Now, remember that I gave you an order. And now this order is listed on page 239 in the yellow box. So this is the order that I gave you. And I told you when I taught it, I said, make sure you follow the order or you're going to get the wrong graph. So what is the transformation order?
Horizontal shifting.
So left or right. And we know the last thing is up or down. Okay, what's in between?
Stretching or shrinking.
And we called it stretches or compressions. Or shrinking, whatever you want. Depends on what book you're looking at. And the number 3 were the reflections, right? All right, so in the correct order, state the transformation. So remember that this is H. These guys are A and B. These guys are negatives, and these guys are K. So do you have an H? No, you don't. So that's out. Okay, do you have a stretch or compression? Do you have an A or B? Well, don't you have a B? Because doesn't the form look like this? Right? For a general function? So what are you going to say? Is this a stretch or compression? And is it horizontal or vertical?
It's a compression because you have to flip it, right?
Yeah, it's a horizontal compression by 1/2. Okay, reflections are next. What's this mean? It's outside. So is that a reflection over the X or the Y? X. Remember my arm? That's a vertical movement, right? Reflector over the X is vertical. And what's this mean?
It goes down one.
Okay, does anybody have any questions about this? Now, if we had an A, if we had a number in front, you don't flip it. It would just be a vertical stretch by 2. Okay, so horizontal compression, horizontal means X. So what you're going to have to do is off to the side of your paper, you're going to have to multiply -2 times a half, which is negative 0 times a half is 0, and 2 times a half is 1. Do some work off to the side. So these are all 2, 2, 2. So now we reflect over the X is negating the Y. So leave the X alone. Negate the Y, negate the Y, negate the Y. And means Y. So leave the X alone. So down means -1 would be -3, -1 would be -3, -1 would be -3 for this problem. Now I'm going to make that dotted because it's not really there, and you don't have to graph it if you don't want, but you do have to graph this one. First one is left 1 down 3, 0 down 3, and right 1 down 3. So does that look like it was horizontally compressed? Does it look like it was reflected over the x-axis and shifted down 1? Yes, it does, right?
Yep.
So on this assignment, make sure that you write the original problem on the exam that you take with this and state the transformations. You're going to show the transformational points, and you're going to graph. Just do what I'm saying so that you can do this stuff later on. All right, would you like me to work another problem, or are you okay?
Yes.
Okay. Can I erase this one?
Yeah.
Okay, let's go to a different graph. Let's do number 52. Says that your new g of x is going to do what to f? It's going to do 2 times f of x minus 1. So this is not a parent we know about. It's not a quadratic. It's not a cubic. It's not a cubed. It's not absolute value. It's nothing that we know about. It's this weird graph. And this weird graph is a function. He just has an equation. And he's left 4 down 2, 0 up 2, right 2 up 2, and right 4 0. And he looks like this. And state the transformation. So this is the f function. You can either not draw him or make him dotted. It's not really there. State the transformation. Can you go left or right? Do you have an H?
Yes, you have an H.
So what are you going to go right or left?
Right.
And the reason why is that negative is part of the form. Okay, do you have any stretches or compressions? So is this A or B? Is it A or B? What is it? Is it vertical or horizontal?
It's A.
It's vertical. Because it's outside the function. So it's a vertical what? Is that a stretch or compression?
Stretch.
It's a vertical stretch by 2. So A doesn't flip. It's only B you have to worry about. Don't worry about A. A, if it's 2, 3, 4, 5, 6, it's a vertical stretch. If it's a proper fraction like 1, 2/3, 5/8, 7/9, 11/12, vertical compression. This is a vertical stretch by 2. And that's it. So write down your points. Left 4, down 2, 0, up 2, right 2, up 2, and right 4 is 0. So right 1 means add 1 to x. So when you add 1, add 1, add 1, add 1. Y stay the same. Vertical means multiply the y by 2. 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 So you're done. So for the g function, we're going to go left 3, down 4. We're going to go right 1, up 4. We're going to go right 3, up 4. We're going to go right 5, 0. So here's your graph. Now, does that guy look like he was shifted right and vertically stretched by 2? Now, vertical stretch looks like this, right? So it looks like he was stretched. And it does look like he was shifted right, right? Do you guys have any questions? Okay, there's one of 2 things you can do in your teams today. You can either work the globe problems for the exam, make sure you know how to do 5 and 7 in a 1.5, or you can start on this assignment. Now listen carefully. I gave you 1 week to do this assignment. That's less than 10 problems per day. So my friend, asked me, are you giving him too much work? It's like, I'm giving him 10 problems per day. Can't they do that? So I'm paying attention to everything. Paying attention to the number of problems I give you on exams. I'm paying attention to the types of problems I'm giving you. I'm paying attention to the number of problems. So come on, do your part. So I believe you can do 10 problems per day. So you can either start on this assignment or you can study for the exam, but later on, make sure you're studying for the exam for tomorrow. Okay? It's 11:30. We're not coming back here. Class is over at 12:10, so you got quite a bit of time to work. Please work out loud. Make sure that you're asking questions if you have questions, and make sure that you're working together. Okay, I'll see you in the teams.